In this video, I'm going to go over two main topics. We're going to go over inverse functions and domain and range. First of all, we're going to start off with the topic of inverse functions. Here is the question, here is the answer. I'm going to show you two ways of doing this question. In these kind of questions, you've always got the inverse function given to you with a specific coordinate. So let's imagine that this inverse function is clearly equal to y. In this instance, we've been given that if the x coordinate of the inverse function is -3, we're going to be given y. Now, because this is to do with the x coordinate, in the original non-inverse function, we're going to have to substitute this for the y coordinate. So basically, when we go from one to the other, we just swap the position. So the x of -3 swaps to -3 in the f of x function. So what does this actually mean in practice? Well, first of all, we are going to have to rewrite out the equation, but instead of writing equals y, we're going to write it equal to -3. So we're going to write down -3 is equal to x divided by -5x plus 6. Now you can do this with normal algebra solving. So what would I mean by that? Well, let's rearrange the equation. We've got a denominator with x on the bottom, so we want to eliminate that. So we're going to times both sides by the denominator from the right-hand side of this equation. So we end up getting -3 brackets -5x plus 6. And then we're going to have this equal to just x. And then we want to separate the terms so that we just have x on its own. -3 times -5 is positive 15x, -3 times 6 is going to be -18, and then this is going to be equal to x. And all we need to do is rearrange this so we have the x's on the left, so 15x minus 1x is 14x, and then 14x minus 18 equals 0, so we're going to put the -18 so it becomes positive 18, and then last but not least we're going to have x is equal to 18 over 14. In this course you can leave your answer as an unsimplified fraction, that's absolutely fine, but ideally you would simplify it if you've got time, which would be 9 over 7. Now how would you do this on the calculator? Well, what we're going to do is we're going to open the calculator, and on the calculator we're going to assume that this is an equation we need to solve, and there's two parts to the equation. This is part 1 and this is part 2, and we're going to put them on two different lines of the calculator. So you press y equals, and you're going to put the right hand side, I'm going to put that as y1. So we're going to do x divided by brackets -5x plus 6, close brackets, and then the second part's going to be -3. Make sure you select the small -3, then we press graph. Now, it says I've made an error, so I think the error is because when we start with a term and there's a minus sign in front of it, it should be a small minus. Let's press graph again. And then we have got the blue function, which is going to be this function on the right hand side, and then we've got the -3 line. So in order to solve this equation, we need to find out where they're equal. Well, where they're equal just effectively means we are going to be finding the intersect. So let's talk about how we are going to do that. So to find the intersect, there's lots of ways you can do this, but using the calculator, there's only one way in this particular menu. If you are struggling with this, go onto the TI-84 help sheet, and you are going to go onto this and then just type in the word intersect after control find, and then it will explain how to do it here. So I'm also going to take a copy of this and put this onto the Jamboard for reference during the video. So what do we need to do? First of all, we need to make sure we've gone to y equals, we've typed in the two curves, we've pressed second trace. We're on step 3 now. So we're going to press second trace. We're then going to go down to number 5, which is the intersect. And then what happens is it jumps from one curve to the next. So ideally we want it to be near the point of intersection, which is where the red and the blue cross around about here. So we're going to press enter on the blue, then it jumps to the red, enter on the red, and then enter roughly where they cross. You don't need to be specific with this, it generally works out for you, and it's come up with the answer of 1.2857, and if we write 18 divided by 14, we could see that the answer is exactly the same. So there's two methods of doing that question, either doing it on the calculator or doing it algebraically. So all these questions here are sort of similar vibes in terms of how to find the answer, because you're substituting in each instance this number here as the y for the f of x. Now let's go over a slightly more challenging question. This kind of question is probably going to be too hard for your exam, but I will explain it because perhaps it would be of some use to you. So we're going to have a look at the top question, and it says, what is the value of k if f minus 1 of 5 equals minus 16? So all we have to do is a little bit of substitution, and we understand that if it's 5 for the x in the inverse function, this is going to be the same as the y. So we're going to put this equal to 5, and then we know that the minus 16, if I use a highlighter pen this time, is going to be the same as the x in the function of the original function, the non-inverse. So we're just going to rewrite this equation, but this time we're going to substitute the relevant value. So we're going to have minus 16k, because we don't know what k is, over 8 plus 13 equals 5. So I could start simplifying this. This might help. Minus 16 divided by 8 is minus 2. So it's going to be minus 2k plus 13 is equal to 5. And then if you just solve this equation, again, you can do this on the calculator. You can put this into y1 and this into y2 and then find the intersect. Or this is quite a straightforward equation to solve, to be honest. You are going to get 13 minus 5, which is 8, equals 2k. And then obviously if you're solving, that k is equal to 4, which is given in the mark scheme. So that's how to do this particular question. And the next thing we're going to go on to is talking about domain and range. So I am going to select a random question from inspired.centurytech, and it wants us to find the domain of this particular function. So the domain of a function is basically all the x values that satisfy it. Now, for this question, I would highly recommend you use just the calculator only, and we'll go over how to do that. So we're going to open the calculator, and then f dot dot x just means y is square root of 5x minus 30. So we're going to go into the y equals, we're going to clear what's already there, we're going to put in the square root, and then we're going to just type in 5x minus 30, and then you can have a look at the graph. You can see with this particular graph, it starts at this particular point, and in the table, you can also see there's an error. So you can see the graph doesn't start until x is equal to 6, and y would therefore be equal to 0. So we're trying to look where the error ends, and therefore the error stops. So it stops when x is 6, so y is 0. So the domain is all the particular values for this graph that's satisfied. So it's going to be x is bigger than or equal to 6. You can write it in 3 different ways. Now let's say the question could ask you, well, let's say it might say, what is the range of this function? Now the range is just so simply all the y values. So if we have a look at the graph, we are going to see, if we change the window of the graph, because we can't see much of the graph, we can see it's going up there, we need to see a lot more x, and that's the main thing really. So let's change the x, so it's 100, and let's see if we press graph what's happening. Again, we need to see a bit more y because it's going up here, so let's change the y to 40. This can be quite cumbersome, this practice of changing the different values. There we go, we can see the x and the y start at this point here, and then it continues up and up and up. So we can see that the values are going to be greater than this particular value. So we've decided that x is greater than or equal to 6, and then we can also say that for the range, y is greater than or equal to 0. How do we know that? Well, like what we talked about before, if we look at the table, we can see that when x starts at 6, y also starts for this particular graph. And why does this work algebraically? Well, when you have a square root, it must be a positive number. So it must be positive under the square root or equal to 0. So we ask ourselves, well, how can this be equal to 0 under the square root? Well, what we do is we actually put this equation equal to 0, 5x minus 30. You don't need to do this, but this is why it works, so this might be good for the top achievers in the class. We solve that equation and we know that x is going to be equal to 6. And then we know that in order for this equation to work, we know that x is going to be equal to 6, or from what we've seen in the graph, all bigger. So that's perfect. And then last but not least, you might decide, well, I get this method a bit better, the one on the right hand side. So how could we expand on that then to find the range? Well, what you could get is the 6, and then you just substitute it into the function. And we know that if we substitute 6 into this equation, we're going to get the square root of 0, which is going to give us 0. So we know that y equals to 0 is a possible value, and then everything else is going to be bigger than that, because we can see from the graph that y is always going to be bigger than 0. Let's go over another question like that. Let's go over something which is perhaps a little bit more challenging than that. We might get a question as this, and we're going to copy and paste this. I'm going to start off with doing it algebraically. We know for a square root to work, it's got to be positive. So we've got to decide, well, what will make this positive or equal to 0. So if we solve that, we can say that the only way this can equal to 0 is going to be x is equal to -3. So there we go, that's why x is greater than or equal to -3, and you can use the graph to actually check this out properly. So if we go on to this, we can type it in. So we've got 5x divided by the square root of 3x plus 9, and then we could close the brackets. Sometimes you don't need to. We look at the graph, and there's going to be a point here to do with -3 for the x. Let's have a look. So if we scroll up the table, you can see that we have actually got an error at -3, and that's why it's going to be bigger than or equal to -3. And if it's ever exactly equal to -3, that's going to be a problem, because for this particular problem, we would then generate a denominator of 0, and then we'd have something like this. And we know if you have a denominator of 0, that is going to then tend towards infinity. So if this tends towards infinity, we have a little bit of a problem, because that's going to give us an undefined answer. So if we have anything which is going to be slightly different to -3, so let's say instead we chose something that is bigger than -3, such as -2, let's see what would happen there. We would have 3 times -2 is -6, -6 plus 9 is square root of 3, so it's going to be the square root of 3, and then on top it's going to be -10. So that's still going to give us a valid answer, but we cannot put our answer exactly equal to -3. You can probably see this in the graph as well. If we sort of zoomed in, and we are going to minimize the x max to say 10, and let's have a look at the graph now. There we go. And then we could use the cursor, and we could sort of see what's happening around about -3. And actually I would like to see a lot more of the y, so we go to the window, we go to the y minimum, let's change this to a -100 to see what the pattern is, and we can see at -3 we've actually got an asymptote, and if you use your knowledge from M5 extended, you can work out when there's going to be an asymptote. This is a vertical asymptote, and it's going to happen at the point where this square root is equal to 0. So this is a little bit above and beyond the course, but I wanted to explain the why so that you understand, so this can take you for the easier question.